Welcome. Today we explore the powerful ideas that shape scientific thinking, theories, models, and paradigms. You will learn how paradigms evolve, and we will uncover one of the most impactful modern paradigms, the paradigm of design science, where creating is just as important as explaining. We have already seen that scientific inquiry begins with careful observation. From those observations, scientists form a hypothesis, a proposed explanation for what they have observed. That hypothesis is then tested. If it holds up under repeated experiments or data analysis, it is supported. Or if it fails, it's rejected and rethought. As this process continues and more evidence is gathered, a broader understanding can emerge. This is when scientists begin to form a theory. A theory connects many findings under one conceptual framework. Because theories can be abstract, scientists and lecturers often build models, simplified testable representations to help work with and communicate the theory. And over time, as certain theories and models dominate thinking in a field, a paradigm emerges, a shared way of reasoning, studying, and interpreting results within the research community. More specifically, a theory is a broad and abstract explanation of how or why something happens. It builds on evidence but is often too general to test directly without breaking it into smaller hypotheses. For example, in computer science, we might say, as input size grows beyond cache capacity, performance drops due to a reduced locality. That's a theory. It explains a general trend. A model, on the other hand, is a much more concrete example. It's a simplified, often mathematical representation that describes or predicts how something behaves. For example, the cache miss model gives us a function to predict the miss rate based on input size and cache parameters. It's testable and often implemented in simulation or code. And then there's the big picture, the paradigm. A paradigm is the framework that shapes an entire field, how scientists think and what questions are valid and how questions are evaluated. For example, in physics, the shift from Newtonian mechanics to quantum theory wasn't just an idea. It was a paradigm shift, a change in the way science itself understood reality. Science is always evolving, and when a paradigm can no longer explain the evidence, it may be replaced entirely, according to the Kuhn cycle, which is a paradigm itself. Let's now turn to a special research paradigm that's particularly important in the fields like computer science and business informatics, design science. Design science focuses on creating and evaluating artifacts, like models, methods, frameworks, or systems to solve real-world problems. Unlike traditional research that seeks only to explain, design science is about building solutions and learning through the act of design. Remember Vaucanson's mechanical duck. But it's not just building for the fun of programming and software engineering. It aims for both rigor through sound scientific methods and relevance by solving real problems driven by people, organizations, and technology. Once a solution or prototype is built, it's evaluated using quantitative or qualitative methods to test its effectiveness. The artifact may then be refined based on what the evaluation reveals. From these practical results, we extract scientific insights. The knowledge gained through this process contributes to theory, methodology, and future designs. And throughout the entire journey, the process is grounded in rigorous scientific methodology, literature reviews, gap analysis, and a clearly documented rationale describing every step of the work. Scientific knowledge builds layer by layer. It begins with observation, where we notice patterns or phenomena in the real world around us. These observations lead to hypotheses. Some hypotheses are accepted, others are rejected, and together they form the basis for broader theories. Once established, theories are applied through models, simplified, usable versions that help us predict or simulate complex realities. As models are refined and theories evolve, they eventually shape the entire paradigm, the worldviews that guide how science is done in a field. One such paradigm is design science. It's now firmly established as a research approach, especially in business informatics. Here, research is built not just on theory, but on the creation and evaluation of artifacts and prototypes.